Hello everyone, in this video I am going to explain free radical addition reaction. There are many kinds in organic reaction. In that addition reaction is a type. Addition reaction usually takes place in three. Addition reaction is three types. They are electrophilic addition reaction, free radical addition reaction, nucleophilic addition reaction. Based on the species involved in rate determination step, addition reactions are three types: electrophilic addition reaction, free radical addition reaction, and nucleophilic addition reactions. That first electrophilic addition reaction completed, and I have given 7 examples in the previous video. This is what free radical addition reaction. So free radical addition reaction is it has a large scope. It is very very large topic, but that large topic not present in syllabus. So we have only few examples, very limited examples we have here, because free radical addition reactions in alkenes and alkynes it become photochemical reaction. That is a separate chapter, separate branch, separate chapter, photochemical reaction. But all that not present here, only few examples here. Free radical addition reaction. First of all, what is the free radical addition reaction? The addition reaction in which free radical is involved in rate determination step. If electrophile involved in rate determination step, electrophilic addition reaction. If a free radical involved in rate determination step, that is free radical addition reaction. Okay, so example, addition of hydrogen bromide to alkene or alkyne in presence of peroxide. In presence of peroxide. So see, addition of hydrogen bromide to alkene is just electrophilic addition reaction, but in presence of peroxide, that reaction goes free radical addition reaction. In absence of peroxide, addition of hydrogen bromide to alkene, electrophilic addition. If peroxide is present, that goes to free radical addition reaction. So this is what propene, addition of hydrogen bromide, so in presence of peroxide. So ROOR, oxygen bond oxygen. So when oxygen bond oxygen is there, that is peroxide. Oxygen with -1 charge here. So peroxide, in presence of peroxide, this reaction takes place. Free radical addition reaction mechanism, and product it is opposite to, contrary to Markovnikov rule. As per Markovnikov rule, so in HBr, what is positive part? Hydrogen is positive part and bromine is negative part. Hydrogen, according to Markovnikov rule, positive part should attach it to double bonded carbon containing more hydrogen. That means hydrogen should attach it here, bromine should attach it here. But here what happened? Hydrogen attached it to double bonded carbon containing less hydrogen, contrary to Markovnikov rule, and bromine attached here. Okay, so as per Markovnikov rule, hydrogen should attach it here, but hydrogen attached here. That's why this is what this free radical addition reaction proceed according to anti-Markovnikov rule. I will explain what is anti-Markovnikov rule. First take this one. Anti-Markovnikov's rule. This is important concept. Like Markovnikov rule, anti-Markovnikov rule also important. So addition reaction in presence of free radical initiator like peroxides takes place according to anti-Markovnikov's rule. So we are talking about what is anti-Markovnikov's rule. Anti-Markovnikov's rule. It is also called as peroxide effect. Peroxide effect. It is also called as Kharasch effect. Kharasch effect. There are different names for anti-Markovnikov's rule. Free radical addition reaction proceeds via anti-Markovnikov's rule. So what is anti-Markovnikov's rule? The addition the addition of hydrogen bromide, not hydrogen chloride, hydrogen iodide, only hydrogen bromide to alkene or alkyne. Alkene or alkyne takes place contrary to Markovnikov's rule. Contrary to Markovnikov's rule. That means you must know what is Markovnikov's rule. Positive part attached to double bonded carbon containing more hydrogen. That is Markovnikov rule. Here this is the opposite. Okay, right. Addition of hydrogen bromide to alkene, addition of hydrogen bromide to alkene takes place in ionic mechanism. That is what Markovnikov's rule. But addition of hydrogen bromide to alkene in presence of peroxide. This is important. In presence of peroxide takes place in free radical mechanism, free radical addition reaction mechanism, or free radical mechanism. Okay, right. Next important point, that peroxide effect not present on HCl and HI, only present on HBr. That means only present on, not present on HCl. HI mean only present on HBr. That means anti-Markovnikov product free radical addition mechanism takes place in case of hydrogen bromide addition only. Okay, right. So first, what is anti-Markovnikov rule? The addition reaction of hydrogen bromide to alkene takes place contrary to Markovnikov's rule. Addition of hydrogen bromide to alkyne in presence of peroxide takes place in presence of peroxide takes place contrary to Markovnikov rule. Contrary mean opposite. Contrary to Markovnikov's rule. This is called as Markovnikov's rule. This is called anti-Markovnikov rule. This is called anti-Markovnikov's rule. Anti-Markovnikov's rule. In presence of peroxide, reaction takes place opposite to Markovnikov rule. That is called as anti-Markovnikov rule. Addition of hydrogen bromide to alkene takes place in general. Addition of hydrogen bromide to alkene, ionic mechanism, H plus Br minus. But addition of hydrogen bromide to alkene in presence of peroxide takes place in free radical mechanism. Okay, in presence of peroxide, free radicals are formed, hydrogen free radical and bromine free radical. In Markovnikov rule, that means in absence of peroxide H plus Br minus. Here H free radical, Br free radical. Peroxide effect not present on HCl and HI. Only present on HBr. Anti-Markovnikov rule only for HBr. Okay. Right. Take this one. I will explain mechanism. Okay, what I am saying, taking propene, addition of hydrogen bromide in presence of peroxide. In presence of peroxide and sunlight, this reaction takes place. CH3, CH2, CH2 and Br. Anti-Markovnikov's rule. So if you see mechanism of reaction, you can understand better. Mechanism involves 3 steps. Step 1, initiation. How this reaction will begin. Initiation. So, in presence of sunlight, UV light, in presence of sunlight, what happens here? In presence of sunlight, homolytic bond cleavage takes place. Homolytic bond cleavage takes place. RO free radical and RO free radicals are formed. That RO free radical formed first, that comes to HBr. In presence of hydrogen bromide, in presence of free radical, hydrogen bromide takes homolytic bond fission. In presence of free radical, that is active species, that takes homolytic bond cleavage. That forms hydrogen free radical and bromine free radical. This hydrogen free radical with RO free radical form ROH. Plus what is formed here? Bromine free radical. Bromine free radical will form. That is initiation. Next, propagation step. Propagation. So propene CH3 CH double bond CH2, bromine free radical. In presence of that bromine, this homolytic bond cleavage takes place. Here addition follows. Addition possible in 2 ways. One way, bromine attached here, other way, bromine attached here. Okay, if bromine attached on the above, so 2 I am writing, just I want to write 2. And here, this is another 2 ways. So if bromine attached here, what happens? CH3 and CH here free radical. This double bond becomes single bond. Here bromine is added. Okay, that is one possibility. If bromine added here, then what happens? If bromine added here, then CH3 CH, here bromine is added, double bond become single bond, and this is become free radical. Okay, between these two, which is more stable? Between these two, which is more stable? Compare, this is what primary carbon free radical. Primary carbon free radical. This is what secondary carbon, which is more stable? Secondary more stable. Secondary carbon more stable, because how many alpha hydrogens here? Number of alpha hydrogens here are, this is alpha carbon, this is alpha carbon, alpha 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 carbon, this is alpha carbon. How many? 5 alpha hydrogen. 5 alpha hydrogen, more hyperconjugation, more stable. Here for this is alpha carbon and this is beta carbon. Only alpha carbon hydrogens involved in hyperconjugation, only one alpha hydrogen. That's why this is what this is what more stable, and this is what less stable. Reactions proceeds through more stable intermediate, less stable. So that's why major portion of the reaction proceeds through this reactant. That's why the product corresponding to that is more stable. Okay, so this is second step. So in second step, next HBr, addition of HBr. If HBr added here, what we can write? If HBr added here, so H comes here, H free radical comes here, or otherwise you can also understand like this. First of all, take up to here, right. Consider this is A and this is B. What is A? CH3 CH free radical, secondary free radical, CH2Br, and this is A. What is B? CH3 CH2, here not, this is not CH2, CH Br, this is B, here free radical. So now addition of H free radical. First Br free radical addition, after Br free radical addition, next H free radical addition, or one more HBr. You can take one more HBr. In HBr, homolytic bond cleavage takes place. Free radical initiator. Free radicals are free radical initiators. Free radicals again initiate free radicals formation. This free radical here initiate free radicals by homolytic bond cleavage. This free radical initiate free radical here. Then what will form? Hydrogen free radical combined here to form CH3, CH here Br and CH3. This is less amount or not? B is less stable. This is less stable or not? Yes, less stable intermediate. So this product is minor. Markovnikov product is minor. So here H free radical added here, that forms CH3, CH2 and CH2 here Br. This is what secondary carbon free radical, more stable. That means this is what major product. This is anti-Markovnikov product or not? Yes, anti-Markovnikov's product. So what is the reactant? CH3, CH double bond, CH2, addition of HBr. Positive part this is, negative part this is. So positive part should attach it to double bonded carbon containing more hydrogen. Markovnikov product. Bromine attached here. This is what? Markovnikov. This is one. Markovnikov product is minor, opposite is major. This is about anti-Markovnikov rule. So So in anti-Markovnikov's rule, mechanism is free radical addition reaction mechanism. Next, termination reaction. Take this one first. Next, termination. Third step is termination. If this step takes place, reaction is going to be stopped. Termination. Termination step. Termination or termination step. Step 3, termination step. Okay, here see, if CH3 CH free radical CH2 Br, this is secondary carbon free radical stable. If it combines with Br free radical, this one, then reaction will going to terminate, close. If this comes here, if bromine attached here, reaction will be closed. Then the product is CH3 CH, here bromine, and this is CH2, here also bromine. If usually H free radical add here, if Br free radical add here, reaction going to close. Okay, right. This bromine free radical required for homolytic bond cleavage of propene. So every bromine free radical again continue the cleavage of homolytic bond cleavage in propenes. Otherwise, if bromine free radical added here, there are no bromine free radical, then alkenes do not undergo homolytic bond cleavage, further reaction do not take place, reaction will be closed here. Or otherwise, this is one possibility. If one free radical, one of such free radical combined with another, again this one CH, I will write down, it combined with again one more. If these two form a bond, then also reaction will be going to close, reaction will terminate. So here bond formation takes place between this carbon, H here, CH2Br. Here what? CH2Br. If this reaction takes place, that also leads to termination of the step. Or if one bromine free radical combined with another bromine free radical, then also reaction will close. Br2 formation takes place. There are no bromine free radical, no homolytic cleavage of propene, no further reaction. So if any one of this takes place, reaction going to close. 1, 2, 3. So this one or this one or this one, any one of this takes place, reaction going to close. Okay, right, take this one, I will write one question.